Before the world we know, there was a different Earth, a world without the air we breathe, a world waiting for a change. Before the world we know, there was a different Earth, a world without the air we breathe, a world teeming with life of a different kind. This is the story of a revolution, a story of how a tiny organism changed everything. Then came a turning point. A tiny organism known as cyanobacteria began rewriting the script. They captured sunlight, created energy, and released a dangerous waste product, oxygen. To most life at that time, oxygen was poison, the ultimate destroyer. This event, known as the Great Oxidation Event, triggered a mass extinction, wiping out countless anaerobic organisms. But life is resilient. In the face of this crisis, some organisms evolved new ways to not only survive but thrive in an oxygen-rich world. And so from a tiny organism, a new world was born. A world of blue skies and breathable air, a legacy of life written in oxygen. Billions of years ago, Earth was an alien world, shrouded in a toxic atmosphere devoid of the oxygen we breathe today. This early atmosphere, rich in gases like methane and carbon dioxide, offered no protection from the sun's harsh UV radiation, and life was primarily anaerobic, thriving without oxygen. Then, a revolutionary change began with the emergence of cyanobacteria, microscopic organisms that developed chlorophyll-based photosynthesis. These tiny life forms harness sunlight, using water as a fuel source and releasing a new, powerful byproduct, dioxygen, or O2. Initially, this newly produced oxygen was consumed in vast quantities by dissolved iron in the oceans, leading to a spectacular geological phenomenon. Thrust-red oceans cleared, forming massive bands of iron-rich rock known as banded iron formations, or BIFs, which stand today as monumental evidence of this ancient chemical reaction. Over millions of years, as cyanobacteria populations expanded, oxygen production outpaced consumption, and free oxygen began to accumulate, first in the oceans, then escaping into the atmosphere. The atmosphere shifted dramatically from a weakly reducing environment to an oxidizing one, fundamentally altering Earth's chemical balance. This monumental change, known as the Great Oxidation Event, had profound consequences, beginning with a drastic impact on Earth's climate. Oxygen reacted with methane, a potent greenhouse gas, converting it into less effective carbon dioxide. This weakened the greenhouse effect, plunging Earth into a series of devastating ice ages, known as the Huronian glaciation. Simultaneously, UV radiation split oxygen molecules, leading to the formation of the ozone layer, a protective shield that would eventually allow life to colonize land. For the anaerobic organisms that had dominated Earth for billions of years, oxygen was a deadly poison. Life died in waves, in what is sometimes called the oxygen crisis or oxygen holocaust. Yet within the chaos, a new path emerged: the rise of oxygen-breathing life. Organisms capable of aerobic respiration evolved, harnessing oxygen for a far more efficient way to produce energy. Geological evidence like the banded iron formations and the appearance of red beds, sedimentary rocks colored by iron oxides, vividly tell the story of this oxygenation. The disappearance of detrital pyrite and uraninite, minerals unstable in oxygen, from the geological record further confirms the widespread increase in atmospheric oxygen. Sulfur isotope analysis, revealing the absence of mass-independent fractionation, provides another crucial piece of evidence, marking the point when oxygen became prevalent. The Great Oxidation Event was not a single instantaneous event, but a prolonged transformation, fundamentally reshaping Earth's environment and paving the way for the complex life we see today. It remains one of the most significant climate events in our planet's history, a testament to the powerful interplay between geology and biology. This was the first planet-wide engineering project carried out by life itself, a monumental transformation that reshaped our world. Earth's chemistry, climate, and ecosystems were fundamentally rewritten by this incredible event, setting the stage for everything that followed. Without the Great Oxidation Event, the very foundation for complex life as we know it would never have been laid. There would be no animals, no intricate food webs, and no diverse species inhabiting our planet today. Indeed, there would be no us, no human civilization, no consciousness to ponder the wonders of the cosmos. The Great Oxidation Event reminds us that even the smallest forms of life possess the power to reshape an entire world on a grand scale. It was a testament to the profound influence of microbial life, a silent revolution that transformed Earth's atmosphere and oceans. This pivotal moment led to the formation of the ozone layer, shielding the surface from harmful radiation and allowing life to colonize land. The rise of oxygen also triggered massive geological shifts, including the deposition of vast iron ore formations across the globe. These changes were not instantaneous, but unfolded over millions of years, a slow yet unstoppable march towards a new planetary state. The Great Oxidation Event was a critical bottleneck, a period of immense environmental stress for anaerobic life forms. Yet it paved the way for the evolution of aerobic respiration, a far more efficient way to generate energy, fueling the rise of multicellular organisms. This event fundamentally altered the course of evolution, leading to an explosion of biodiversity that continues to amaze us. From the simplest bacteria to the most complex mammals, all life on Earth bears the indelible mark of this ancient transformation. It underscores the interconnectedness of geological processes and biological evolution, a dance between rock and life. Earth's history is a grand epic, a saga of change and adaptation written not by giants, but by microscopic architects of destiny. These tiny organisms, through their collective actions, orchestrated the greatest environmental engineering feat in our planet's history. Their legacy is the breathable atmosphere we enjoy, the complex life that surrounds us, and the very existence of our species. The Great Oxidation Event remains a powerful reminder of life's enduring capacity to transform and shape its world.